Assalamualaikum and very good morning. I bid to Dr. Shamarina and my fellow friends. Today, the title of our presentation is Ronald Fisher and P-value. So, I'm the first presenter of Group 3, looks like Rashim binti Muhammad Yusuf Rashim. I'm going to give a brief introduction about Ronald Fisher. Sir Ronald Elmer Fisher, or also known as Ronald Fisher, was born in 1890 in London and died in 1962 in Australia. He was British analysis and genetics who implied the use of statistical procedure to the outline of logical tests. He was famously known as the father of modern statistical inference and an end of statistical genetics. He was the first one who introduced the idea of significance level as the method to look at the disparity between the data and the null hypothesis. Fisher started to be the statistician in 1919 at Rothamsted Experimental Station in central England as an agricultural research. He used his mathematical knowledge on biological data and invented the tool for modern experimental design. In his plant breeding experiment, he introduced the principle of randomization in plant breeding experiment. So, in 1921, he introduced the method of variance or ANOVA and F distribution in the 1924. His book, Statistical Methods and Scientific Inference, was one of the summary on his statistical work.
Hi, my name is Nurul Aiman Shazudin Tamdan. So I proceed to the Ronald Fisher view on the p-value. So basically, the Ronald Fisher viewed on the p-value as an informal index to be used as a measure of disagreement between the data and the null hypothesis, which means that we include the data and the null hypothesis. So the Ronald Fisher stated that or suggested that he used 5% significance as a standard level for concluding that there is evidence against the hypothesis tested. So for the p-value between 0.1 until 0.9, which means that no reason to suspect the hypothesis tested. And if the p-value is below 0.02, it strongly indicated that the hypothesis is failed, which means that the hypothesis is rejected. And Fisher said that the Fisher method to combine with the p-value is one of the most powerful combining function that can be used for non-parametric combination. And Ronald Fisher is the one that introduced the p-value in 1920 because he wanted an objective method to comparing the data to null hypothesis. And he also viewed that the p-value calculation will include the effect size, sample size, and variability of the data into a single number. And the p-value calculation will be precisely tell how the consistent of data sample with the null hypothesis, and this p-value will provide a quantitative strength of evidence against the null hypothesis stated.
Hello, my name is Tewan Jane and I'm going to proceed with the definition of p-value. P-value is the conditional probability which the calculation is conducted based on an assumption where the null hypothesis is true, as stated by Dore in 2010. P-value is also an index used to describe and explain the strength of an evidence against the null hypothesis. It also describes the likelihood that any observed difference that occur between groups are due to chance, as stated by Dahiru in 2008. So as we can see in this picture, the p-value is located at the area in the tail of a probability distribution.
Hi, my name is Siti Narshuhaila, so I will proceed with the interpretation of p-value. So basically, a p-value is considered to be small if it is similar or smaller than 0.05. This means that the observed difference is unlikely to be due to chance, and then it is a strong evidence against the null hypothesis, and therefore we will reject our null hypothesis. A large p-value is considered to be when the p-value is larger than 0.05. This means that there are no difference between groups other than due to chance. It is a weak evidence against the null hypothesis. And finally, we will accept our null hypothesis.
Hi, I am
recap. So I'm going to proceed on the importance of p-value. P-value is often common use in hypothesis testing, whether it is alternative hypothesis or null hypothesis. Secondly, it is give measure strength of evidence to researcher, whether it is strong evidence or weak evidence indicated by value of probability, which is more than 0.05 or less than 0.05. Then it is used to interpret the significance of results, whether a comparison between the dependent variables or independent variables, or effect between two dependent variables into independent variables. Lastly, it is used to justify hypotheses of the experiments, and researcher will achieve their main of the objectives.
Hi, my name is Nur Fatiha and I will proceed with the last part of this presentation, which is misconception and justification of p-value. There are two common mistakes in analyzing the result regarding the p-value. So here are the two facts that should be considered in analyzing the p-value of the experimental result. Firstly, the small p-value indicate there is a significant difference in mean. However, it not tell about the practical impact. Secondly, the small p-value provides statistical evidence to reject the null hypothesis. However, it does not prove the truth of alternative hypotheses. For example, if a jury fails to convince the defendant, it does not mean that the defendant is innocent. It just failed to prove the defendant guilt beyond reasonable doubt. So, as per conclusion, the p-value is very important in experiment to prove that the data we obtain is reliable and provide evidence to reject or accept the null hypothesis, and can become the evidence to against that there is no effect at all in an experiment. So the p-value remain as a important tools in analyzing the experimental result. So that's all from us. Thank you.